Okay, so thank you everybody for being here today with us for this new meeting on the Financial Line Seminar. Our guest today is Joe Roussos from the Institute for Future Studies, and thank you very much, Joe, for accepting our invitation. And Joe will talk about models, and in particular, normative models in economics and finance. And so thanks again, Joe, for being here. And without further ado, we can start the meeting. And the floor is yours.
Thanks, Emiliano. I'm very glad to be here today. And as you just heard, my topic is normative models in economics and finance. And my goal is to say something about how it is that models, kind of standard classical models in economics and finance, can be normative. But I'm going to get there through an indirect route. So I'll start by talking about something that is obviously normative, a bit of philosophy, and show that it is modeling. So what it produces are models which are normative. And the reason I'll do that is because it can establish that models can be normative, that they can involve norms, that they can generate normative claims. And then from there, I'll take the step to talking about economics and finance more broadly. And the way that I'll do that is that the piece of philosophy I'm going to talk about is decision theory as it takes place in philosophy. And of course, decision theory produces this theory of rational choice that underlies much of microeconomics and finance theory. So what do I mean by normative? Broadly speaking, I'm using the term in a wide way to characterize the kinds of things that ethicists are interested in. So you can think of there being two large kind of categories of things that fall under this heading. The one is evaluative claims. So we might assess the value, the goodness or badness of something, or the value relations between things, which are better or worse. And what we are assessing, I've just put here, are states of affairs, but that could be a very broad category. We could be evaluating the outcomes of decisions, or like some of my colleagues who do population ethics, we could be evaluating populations, which populations are better in a moral sense. The other part of the normative is the part that relates to actions, the part that gives guidance about which actions are right or wrong, which things are permissible or impermissible, the sort of deontic aspect. And these actions, again, could be anything. It could be financial decisions relating to investments, or it could be some of these cases that ethicists spend a lot of time on, thinking about things like the permissibility of killing someone in self-defense if they attack you. So the important thing for me in this talk is to contrast the normative with the descriptive. Typically, models in the sciences aim to describe how things are, how they work, why things happen, and so on. They do not typically say anything about how good things are. It's traditionally not a sort of role that the sciences take. And they also don't directly say what agents ought to do. Now, they can, of course, be used in some way for these purposes. So there's a very thin sense of the normative use of models that I just want to talk about right up front, because there's a very easy way that you might think models could be normative. Like suppose that I'm an investment advisor and I talk to Emiliano and I say, well, here's a model that shows that you'll make more money if you invest in an index fund than in Bitcoin. And so I show this result, and then I say you ought to invest in the index fund because you will make more money. So there's an ought there. It's a kind of normative statement. That's a prudential ought. It's about a set of goals, making more money. But it's not really the model which is generating the normative content there. The model just describes the likely outcome of some investments. And it's me who connects that to some goals and who makes the normative statement. So I'm looking for a sort of thicker notion of normative modeling. I'm going to try to find ways in which the model itself can be sort of generating the normative claims. So that's the goal, to talk about that kind of thicker sense of normative modeling, and eventually to be talking about that in economics and finance. But as I said, the plan is to start off with this bit of philosophy, normative decision theory, and to sketch this view that I've defended that it is modeling in exactly the same way that science does modeling. That raises a bunch of questions, so I'll spend a bit of time on those specific aspects that are challenging, like the nature of the idealizations that these models involve and how they link to their normativity. And then with that in place, I'll be able to zoom out and talk more about economics. That is the kind of ultimate goal. And I'll close with a kind of connection to performativity, just because that's something that we talked a little bit about in our email exchange. It's really just one slide for us to discuss, hopefully, because I think there are some interesting links between normative models and performative models. So a little bit of like biographical background on how I got into this. So I started off working on scientific models, in particular, those in climate science and meteorology. These are physical models. They simulate the atmosphere of the planet. So they're kind of quite classic scientific models. But it had this connection to, well, both sort of finance and decision in that I worked with insurers who were using these models to price insurance products for natural catastrophe insurance. And my work was always about how decisions are made using models, managing the uncertainty in them. And so I got into decision theory, and this kind of theory that tells us how we ought to make decisions. It's explicitly normative, especially in philosophy. And we do this work using this bunch of mathematics that describes, represents agents, their choices, the consequences of those choices. And to me, because I was reading the theory of models and I was looking at this bit of mathematics, I said, but this mathematics just is a model. So I didn't think that was controversial. And the economists and finance people I talked to didn't think it was controversial, but the philosophers pushed back and they said, no, it can't be a model. It's normative. We are writing down these statements about necessary features of the structure of rationality. Modeling is indirect and idealized, and it just isn't what we're doing. So that's how I got started thinking about normative models. I did what any philosopher would and wrote a whole bunch of papers about how it's definitely modeling. And I started off with decision theory and formal epistemology. And more recently, I've been working on ethics itself and how ethics in the kind of central part of theoretical normative ethics, where people work on utilitarianism and Kant and so on, how they can do and even should use models as a useful method for doing their work. So that's a bit of background of how I got into this. The goal today, as I said, is to talk to you about normative decision theory. So these are models of choice. So I assume most people here will kind of already know about this, but I'll give you just a very brief kind of introduction just so that we're all on the same page. And the idea is that the central object that we study in this theory of rational choice is an agent and a decision situation. So here's a very simple decision situation. I'm late to get to an appointment in the morning, and I think there are two options for how I could get there. I could take the bus, or I could run. Now, if I take the bus, my choice is subject to the situation of the traffic. If the traffic's light, then I get there on time, and I'm cool and calm, and everything's great. If the traffic is heavy, then I'm so late that I miss the appointment. Alternatively, I could run there, and then I'll get there slightly late, but I'll be sweaty and ruffled, and it'll be sort of unpleasant. So that's my decision situation. And the theory of rational choice is meant to tell me something about how I should make this decision. So the theory has these various parts, the options that I have in front of me, how those options relate to the states of the world. These are sort of external features of my environment, and then the outcomes of my choice depending on what the state of the world is. And we take these features and we formalize them. We put them into a kind of mathematical representation in order to realize more kind of concretely and specifically various claims we want to make. So we might use these mathematical descriptions for the options and the states and the consequences, and then we represent the agent as having these two attitudes that inform their decisions, their beliefs, which are represented in the theory by probabilities, and their preferences, which are represented by utilities. And then there's a part of the theory, the kind of central claim of the theory is that the way you should value an option is you should value it at the expected utility of the consequences of doing the option. And then the claim of the theory that I'm interested in, the subjective expected utility theory, is that rational agents choose the option which maximizes their subjective expected utility. So we've started off with these sort of simple descriptions of choice situations. We've applied some mathematics, and we've gotten to a place where we make a claim about what people ought to do. And the goal is basically to talk about this mathematical structure and the claims that philosophers make about it, and to understand in what way it can be described as a model. So let me just give you a little bit of more like concrete example of what it is that philosophers have to say. So here's a bit of text from John Ehrman's book, Bayes or Bust, which is about Bayesianism as a theory of decision and also a theory of confirmation in science. So he says, since probabilities in this theory are interpreted as degree of belief, they'll be assigned to objects which express propositions. So in his model, there are sentences. And then he says the probabilities are going to be functions. They map from a set of these sentences to the real numbers, and they have to have these standard properties, A1, 2, and 3. So the first one says there's a probability assigned to every sentence, and that probability is greater than 0. The second one says the probability of some sentence equals 1 if that sentence is a tautology. And the third one says the probability of A or B is equal to the probability of A plus the probability of B if they are mutually exclusive. So those are the standard kind of axioms of probability. And using them, he derives some other conditions. I've just highlighted two here, P2 and P4. So P2 says if A and B are equivalent, then they have to have the same probability. And P4 says if A entails B, then the probabilities have to respect that entailment. So the probability of B can't be smaller than the probability of A. So this is one part, the sort of belief part of a decision theory. And so what should we make of this kind of bit of mathematics? So some of it could be seen as a description of the properties of people's beliefs. So it's true that people have a kind of comparative attitude of confidence. They're more confident in some things than others. It's true that they can compare the strengths of their beliefs in some things. I'm, more certain that I am in Stockholm right now than I am certain that my kitten is awake. My kitten sleeps all the time. So I can compare my strength of belief in those propositions. It's also true approximately that when things are going well, my beliefs have some of these other properties. They're transitive. So if I believe in A more than B and I believe in B more than C, then I usually, if I'm doing well, I believe in A more than C. And if I know about logical entailments, then my beliefs respect those logical entailments. So there's a way in which this could be a kind of description. But that's not the point. The point of this theory is to generate norms. It's to tell me how my beliefs ought to be structured, how I ought to make decisions, how they ought to fit together with my preferences. So my initial interest was to investigate that and to kind of figure out how it is that this body of mathematics could be part of generating that kind of claim. And as part of doing that, I wanted to understand how the bits of it that are not descriptive are what they're doing, how they can fit into this story. So here to give you just two examples of things that are false if you think of them as descriptions. A1 says there's a probability for every sentence. So I guess if we interpret that, it says the agent has an attitude towards every proposition. And that attitude can be represented by a number. It's precise. If you find any two propositions, then there's an attitude that's precise. You can compare exactly which one's bigger, which one's smaller. Well, that's not true of real agents and their beliefs. They can't always compare the strength of their confidence in completely different topics that are not connected. Nor is it true that they have these attitudes which are exact and precise. If you read together A2 and P2 and P4, all the ones where the right-hand side has a bit of logic. These are part of the feature of Bayesian decision theory, which is that Bayesian agents are logically omniscient. So they know everything about logic. They can they appear to understand all the logical relations between propositions because their beliefs always respect them. And of course, that's not true. If you tell me a random bit of mathematics, I won't know whether it's a tautology. If you just show me two different complicated logical formulas, I won't know automatically whether they are equivalent. So my beliefs and most people's beliefs will not have this structure. So what's going on with those bits? So the kind of hypothesis here is that it's a model. Now, the trick is, if it's a model, how's it serving this normative purpose? Because models are just things in science that do descriptive work. They're idealized representations. So how do we fit in the fact that this is normative? A secondary puzzle is then to figure out how it is that these descriptive disciplines, like economics and finance, appear to be using these same models, because it's these models of rational choice that underlie models of consumer choice or price theory, and so on. So let me just tell you a little bit about models as I understand them, and then I'll try to build this picture on which this is a model, and then fill in the tricky bits of that explanation, of that account. So here I'm just going to draw on some philosophy of science. This is stuff from the last kind of 30 years about model-based sciences, in which philosophers have tried to characterize what it means for something to be a model. And I'm drawing on a kind of, I don't know what you would call it, a trend in philosophy of science, which is a sort of pragmatic approach to theories and models. So if you are familiar with the accounts on which models are like set theoretic structures and theories are represented using sentences and logic and so on, this is not that. This is a kind of looser, more, I guess, realistic in some way account on which models are a certain kind of representation used as a tool for inquiry, but they come with a bunch of common practices. They can be constituted by descriptions, diagrams, common modes of use, and so on. So I'll just highlight a couple of features of models. So I've said that they're representations used as tools for inquiry. They can be either concrete objects or theoretical objects. So I've got two pictures here. The top one is a chemistry modeling kit, the kind of thing that an undergraduate would get. It's got these little spheres that are different colors that represent different elements. And they've got little rods. Some of them are short, some are long, some are bendy. And together you can construct these little shapes that represent molecules. So you can take hydrogen and oxygen and some bonds, and you can make a little water molecule. And so this little plastic object you've created represents something, the real water molecule. Or models can be theoretical. So the one at the bottom is Bohr's model of the hydrogen atom. It represents the atom as a point, the center, the nucleus, and then the electrons are in orbital shells around it at different energy levels. It's represented by this diagram, a description, some laws of physics. Those are all part of the description of the model. In each of these cases, there's a target system, a thing in the real world that the model is a representation of. And the inquiry proceeds by looking at the model, studying it, generating some insights about it, looking at the shape of the little thing that you've built, and then using that to make inferences about the target, so about real water molecules. So in that way, modeling is a kind of indirect form of inquiry. Now, models present idealized, simplified pictures of the world. So they're not fully accurate representations. They're not trying to be. So modelers, when they build these models, they leave out some aspects of the real phenomenon, typically things they think are not relevant. They distort some features of the system deliberately, often to make it easier to work with, or they approximate them in some way because of limitations of their own or their tools, like mathematical tools. And this is core to modeling. It's really helpful, but it's also risky in that when you distort and abstract, you can introduce some additional differences between your model and the real world, ones you didn't think about or didn't intend. Those ones we call artifacts, and those are difficult because You put in some differences that you thought would help you, but now you created some differences which maybe you didn't know about, and it makes it difficult for you to infer about the real world using your model. And the final thing I'm going to say is that models are kind of built for purposes, and these purposes often mean that they perform well only within a kind of limited domain where they're doing the job they were built for. Because when you do this job of leaving some things out, distorting some other things, what's motivating you as a modeler is a purpose. You're attempting to understand a certain feature of a system, and you have some justification for why it's okay to leave this thing out or distort this feature. And those justifications derive from what you're trying to do. But that means that if you hand that model over to someone else, it comes kind of with these things built into it in a way that means it may not work very well if they try to use it for a different purpose. And the result of that is that we often see different models of the same system with different idealizations. So they look like they disagree about the system. And we can kind of understand what's happening there by recognizing that they are purpose-specific tools. So they don't truly disagree. The disagreement's a feature of their purpose. So what I'm going to do now is just take these features, which I draw from the philosophy of science literature, and apply them or look for them in this normative decision theory. So I'll first just do a quick pass to sketch that I think it's plausible that this thing is a model, and then we'll have to deal with the unique features of it, mainly the normativity. So firstly, indirectness. It seems like normative decision theory has this structure. We write down the mathematics. We call it a representation of the agent. We say the probabilities represent the beliefs. The utility functions represent the preferences, and so on. We, in decision theory, in fact, prove these things we call representation theorems that guarantee that the mathematics has certain properties that we assume the thing has, the phenomenon we are representing. And then we use the mathematics to produce some results. We prove theorems, we show relations. And what those are, strictly speaking, is they're just descriptions of relations between these mathematical objects. But that's not what we use them for. We're not mathematicians. So instead, what we do is we read them as statements about the real thing, the group of human beings whose decisions we are interested in. So we interpret the mathematics as saying something about these real agents, their actual preferences, the choice situations they find themselves in. So the mathematics is a tool for studying this class of real agents. So it has, I think, this proxy structure. It is a form of indirect inquiry. So if you contrast decision theorists with behavioral psychologists, what our colleagues are doing is they're putting people into these little rooms and giving them, scenarios and making them do these experiments. They are directly studying choice behavior. We are not doing that. We are indirectly studying it by studying these mathematical systems. Next, idealization. So speaking very broadly, an idealization is just a difference between the target system and the representation. So if you take this sort of high school physics example, where you think about an inclined plane and you're modeling how something will move on the inclined plane, you probably started off by assuming that the plane was frictionless. Now, no real table or whatever it is that you're going to incline will be frictionless. So that difference is an idealization. And in this case, it's introduced in high school physics classes because friction's hard and kids are bad at maths. So the differences are the kind of place that we look for these idealizations, the differences that are put in deliberately by the modeler. And there are many such differences between the mathematics of normative decision theory and the target system, the real agents. So to start off with, the theory only has two attitudes, beliefs and preferences. But we have many more attitudes than those, which might influence our decisions. We have, hopes and all kinds of other things. We have emotions that influence our decisions. They're left out of the theory. Beliefs are represented by probabilities. I've already talked about some ways in which those are different. The probabilities are different from the beliefs. Same goes for preferences and utilities. In the model, preferences are transitive. They are also precise. You can compare utilities precisely. They're complete, so agents have preferences over any two. So The model, well, I guess I shouldn't call it a model yet. The mathematics has differences from the thing that it represents. Now, a key difference from the scientific case is that some of these are normative. So when we're in a high school physics class, we're not trying to say that tables should be frictionless. It's a difference that we introduce in order to simplify the process of teaching children how to do physics. But in the model here, in the mathematics here, in normative decision theory, when we say preferences ought to be transitive, what we're saying to people is, if you're buying ice cream and there are these three flavors, vanilla, raspberry, and chocolate, you just shouldn't have cyclical preferences. You shouldn't prefer vanilla to raspberry, raspberry to chocolate, chocolate to vanilla, and so on. That's a statement about the way they ought to be. So there are these suggestive features of normative decision theory that I think make it plausible that this is a model. It's got indirect inquiry. It has something that looks like idealization. It's a representation, but there are questions that we need to kind of answer to work out, can this really be a model? In the same way the chemistry kit is a model, or the physics example is a model. And those questions are, well, what are they representing? Because they're not trying to describe real agents. And when we try to figure out what a model is representing, we look at what it's trying to describe. Models are usually built with some data. I mean, they may be built with a bunch of theory, depending on the science, but they're often trying to fit some observations. That's kind of core to their scientific use. So what's the data in a normative model? Third question, are these normative assumptions, like the transitivity of preference, are they really idealizations in the same way that the zero friction is in the inclined plane? I mean, they fall under the very loose description I gave. They are a difference between the model properties and the target system properties, but is that kind of enough? And then finally, are these models, I mean, if they're models, are these things purpose-specific in the same way that scientific models are? So I'm just going to go through each of these and kind of sketch a bit of the answer. So first, representation. I think that there is a kind of way in which we can easily say that this is a representation. Firstly, that's just how we talk. When decision theorists are kind of talking about it, we say that this represents the agent, this, the table. When I teach people, I'm like, here's the decision table. This represents the agent's choices. Here are the options. Here are the state of the world, and so on. The bits of maths, the utilities represent the real person's preferences. And I think we can take that seriously. These aren't accurate representations, but that's not a problem because modeling, as we know, isn't about accurate representation. And it's often in these deliberate ways that we make the representation less accurate that we gain the usefulness of the model. So in this case, I think what we need to do is understand that representations often involve representing something as something else. So here's a classic example. It's Winston Churchill represented as a bulldog. This is a caricature. It's meant to kind of represent something about how the British people saw Winston Churchill. So it's from the Daily Express in 1940, and it says the affectionate way in which most Britons regard the new prime minister. So, bulldogs are sort of pugnacious, and there he is standing on Great Britain defensively. The fact that he's drawn as this animal he's quite clearly not is there to represent certain features of him by drawing on these features of the thing he's represented as, the bulldog. So my proposal is simply that normative models are doing exactly that. The target is real agents, people like you and me. They're just represented in the model in this normatively idealized way. So they're represented as having these properties. Which properties? Well, the properties that we ought to have. So it is a model of real agents, an abstracted model. So it's not, the one I wrote down there, the one Ehrman wrote down is not a model of anyone in particular, but it's a model of a generic agent represented as an ideal agent who has complete and transitive preferences. Why? Because they ought to, who has logical omniscience and so on. I'll come back to this bit. But I think that actually the core problem, it does not lie in representation. These things, I think, are straightforwardly representations. The fact that they don't aim at being accurate is not a major problem. Secondly, data. Scientific models aim to fit some data. So what's going on in normative models? Well, I think there are two kinds of data that normative models are working with. The first is descriptive. When I put up the Ehrman text, I said some of it could be read as a description. So we do build these models to represent features that agents do have, some of those features. So agents do have beliefs and desires. And we represent those attitudes in a way that respects actual properties that they have. So we want the direction of fit to be right. Beliefs are about the way the world is. They succeed when they're true. All those features are kind of things that we want to be in the model. But they also have what I call normative data. So the model is built to fit our normative judgments or intuitions about whatever this thing is that we're doing. So in the case of decision theory, we have certain judgments about the structures of preferences or of beliefs. So to take the example I talked about before, we think that preferences should be transitive. You shouldn't have the cycle in preferences for ice cream flavors. And why is that? Well, there are these classic arguments like the money pump argument, and we have the judgment that being money pumped is bad. We have the judgment that choosing an option which is worse by your own lights is bad. Well, we don't usually use the word bad, we usually use the word irrational. But what that is it's a kind of direct normative judgment. And that judgment is the thing that we are building the model to fit. We want the model to represent accurately our judgment that being money pumped is bad. And so we put in an assumption like transitive preferences, which guarantees that the agents in the model have the property that we think is the good property to have. So we kind of fill out the description of the agent with these two parts. Got this little stick figure here with the descriptive half and the normative half. And they come together to characterize this ideal agent in the model, which is the way that we are represented. We real agents are represented as these ideal agents. So this brings us back to this notion of idealizations, because I said that idealizations are these differences between properties of the target and properties of the representation. And now I have this idea of normative data. So when the normative data are put into the model, they show up as a difference between the representation and the target, us. So that's how we get these differences that I just read off of Ehrman's text: transitivity, logical omniscience, etc. So we can now call those normative idealizations. They are put in deliberately. Why are they put in? Because we want the model to fit some data. So in that sense, they're different from descriptive idealizations. Those are usually moves away from some kind of observations. They're moves away from the empirical reality that we observe. But these things are also moves away from the empirical reality we observe. So that's why I think it's justified to call them idealizations. They're moves away from the way our beliefs really are towards how we think our beliefs should be. And so they're normative idealizations. Okay. Now, the models also contain descriptive idealizations, ways in which the agent in the decision theory are not like you or me, but that are also not normative. So I don't think it's normatively required to have preferences over every option. But the theory says you have to. What's going on there? I just think that's a normal descriptive idealization. It sort of makes things simpler to just say, well, we're just going to represent the agent as knowing what their preferences are over all of these options. So they're both descriptively idealized and normatively idealized. Okay, so now we've got representations, we've got data. I think that these things are idealized in the same way. And so what that means, if we follow the logic from the scientific case, is that I think that they're also purpose specific for the same reason. So in the scientific case, what happens is that the purpose, the thing that you're interested in studying, drives the kind of idealizations that you put into the model. So there's this great example from Teller, where he talks about two models of water. The one model of water, the one at the top, is interested in explaining diffusion. And so it models water as a bunch of little particles that are in thermal motion. So they're kind of wiggling back and forth. And using this model, you can study something like the diffusion of a drop of ink put into the water. The second model is used for something else entirely. It's used to study the flow of water and things like wave propagation. So it models the liquid as a continuous fluid. It doesn't have any particles, and it's incompressible. So these two look like they disagree on the structure of water. One says it has particles, the other has no particles. But each of them is similar to water in respects that are relevant to its purpose. The purpose of, in the first case, studying diffusion, and in the second case, studying wave propagation or whatever. So neither one of them is complete. I mean, they're not giving definitive characterizations of water, but they are each useful. And the way they idealize water is driven by the purpose. It's useful to assume that water is continuous and incompressible if what you're interested in is water flow through a compressed pipe, say, or whatever. So I think that models in normative decision theory are like this too. So I said we only have two attitudes in expected utility theory. We talk about belief and preference. There's no talk of knowledge. Epistemologists love knowledge. Why are we not talking about knowledge? Well, it's not relevant to our purpose. We leave it out. On the other hand, if you're a philosopher and you're interested in knowledge, you can use a different formal model. Epistemic logic is about knowledge, and it's not any good at dealing with decision. So there are these purpose-specific bits of mathematics for doing normative work in philosophy. They have idealizations that are kind of characteristic to the purpose they're put to, and they can't really be used very well for other things. Sometimes we leave out part of the model. So in Aumann's famous agreement theorem, he's kind of working in this economics like decision theoretic framework, but his point in the paper is just to make a claim about the beliefs of two agents. It's kind of about common knowledge. So that model doesn't have any references in it. He just puts in the belief portion to make the claim that rational agents in certain situations should arrive at agreement on their posterior probabilities. So each of those is a model that's constructed for a certain task, and the abstractions and idealizations are motivated for that purpose, and it's not going to be very good at doing things that are not its purpose. Okay, so we can now come back to my initial questions I had about Ehrman. So what's going on with the falsehoods? The model says that I'm logically omniscient. The model says I have a probability for everything. They're idealizations. In fact, in the case of those two, completeness and logical omniscience, I think those are in fact descriptive idealizations. The first one I think is more straightforward. I don't think that you're required to have beliefs about literally any proposition, and nobody has good arguments for that. The second one's a bit more complicated, but I don't think that Bayesian decision theory is interested in whether you're logically omniscient or not. I think it just builds that in because it's not the focus here and it simplifies the analysis. And usually we're not interested in people's logical beliefs. We're interested in the choices they're making. And so it doesn't really matter to us. Okay. So now the big question was, how is it that this bunch of maths can say anything about how our beliefs ought to be structured or how we ought to make decisions? So the answer is they're models. They represent these real targets, people, in a normatively idealized fashion. How do they make normative claims? Well, because we put norms in. So we put norms in the form of these data, which then motivate the normative idealizations, and those generate the normative claims that come out the other end. Now, like all models, they require some care. I mean, they have descriptive idealizations, and those are going to interact now with these normative idealizations. So that could throw up some weird artifacts. Making inferences from models to the target is always complicated. That's going to be true here too. So it's not obvious how this is meant to work. And in addition to the normal questions we have about models, like how do we confirm them? How do we know when they're good? we have these kind of additional meta-ethical problems about, like, how do we know that those norms are the right norms? What does it mean for them? How could you confirm a normative model? I'm going to put those things to one side for the moment, because we don't want to get too deeply into kind of meta-ethics. So in the last few minutes, what I'm going to do is just instead talk about economics. That's what I sort of promised this was going to be about. So we're going to zoom out now. We've been talking about how philosophers do decision theory, but now we want to talk about how economists and people in finance do it. So the first observation, of course, is that economists just are using the very same models. So there's not a very large gap for us to cross here. I talked about Armand's agreement theorem, but I mean, von Neumann and Morgenstern, when they did expected utility theory, their purpose was a descriptive purpose. They were building this kind of microeconomic theory, and other bits of traditional microeconomics and theoretical finance build on these theories of rational choice. Now, the interesting question for us is those fields are putting this model, this sort of same model, to a descriptive purpose. They're trying to do something that's more classically a scientific task, like predict prices. So let's think about what's going on there. Like, I've described this as normative. These assumptions are motivated by our normative judgments, and yet they're being used for this other purpose entirely, making predictions. So I think that a first thing we should observe is that you can make the same idealization, but construe it in a different way. So I described transitivity as a normative idealization. I said we can think about the money pump argument, and as philosophers, we can say you shouldn't be in the situation where you get pumped for money because your preferences are transitive. Now, economists, to be fair, actually often make these sort of blended statements where they'll say both things. They'll say rational preferences are transitive. So you kind of should have transitive preferences, but also real preferences approximate that. And so we can just model them as transitive. And that's kind of a messy mixture. But the second part is the part that I'm interested in. The fact that the same thing can kind of act as a normative and an approximate descriptive idealization. So that's just an interesting fact that we want to come back to. But there's also a kind of broader challenge, an interesting question of what the normative term rationality is even doing in descriptive economics. And I think there are two answers to that. One, I think, is a certain kind of methodological prescription that microeconomic theorists will often say if pressed on this, which is something like the way the theory works is that it assumes the best of people. Rather than assuming that some observed behavior is because people are getting it wrong or being irrational, we assume that they are rational, that they're doing the thing that they ought to do, and instead we seek to explain this behavior as following from a pattern of preferences or some beliefs. So that's a kind of prescription for how to go about modeling behavior. A second thing that could be going on is a kind of lingering normativity, that these, although the aim of economics is sort of officially descriptive, the models are often used in the end for some kind of decision-making purpose, whether it's policy or kind of private decision-making. And it's a feature of these models kind of descriptively that if you pit rational actors in the model against irrational actors in the model, the rational actors will do better in the long run. And so there's a way in which it's easy to slip into just accepting the normativity, saying you ought to best act rationally in this way, even if your job as an economist is sort of conceived of as being the descriptive job. So there are these different ways in which normativity kind of slips into the field. But I want to go back to this idea of the same idealization being used in these two ways, the transitivity of preference being normative for the philosopher and being descriptive for the economist. So one place that I said that normativity enters the model is in this normative decision theory is through the data. So the normative judgments are used, the model is built to fit the normative judgments, And so you get these normative idealizations. So in that story, we kind of start out by saying we have the judgment that models should be, that preferences should be transitive, and then we build the model so that the agents do have those transitive preferences. But there's another way of thinking about it, which is just you're trying to model these people and they are approximating a certain property, and the model will be much simpler if they have that property. So the very same thing can be put into the model for a different reason. So it's just as important the purpose to which the model is put. So if you pick up my model, which I built in the first way, thinking that I was doing this normative decision theory, but you're an economist, and you just put that model to descriptive use, kind of rereading the same assumptions as descriptive idealizations, then it's not a normative model. A normative model is a model that's put to normative purposes. So there are these two kind of ways in which models are normative, both in the justification of them and then in the kind of ultimate use of them. So what that tells us is that models aren't inherently normative or non-normative. It's the intentions of the modeler and the model user which determine this. So that's not always going to work. If I start out making the normative model, there may not be a compelling descriptive reading of it. So it's not always going to be the case that you can pick up my normative model and put it to a descriptive use. And in the same way, most descriptive models can't be reread as normative models in this kind of thick sense I'm interested in, because there's just no reason to construe most assumptions as normative, as kind of justified by some normative data. So the key questions are, does the modeler justify any of the assumptions or idealizations normatively? And then is the model being used to generate normative claims? Okay, I'm running out of time. So let me do one, I'll do my last slide on performativity. Because I promised to make this connection that models in economics and in finance have this additional role. They don't just describe, they also have a role in which they end up changing the way that the phenomenon that they set out to describe in fact occurs. So this, just to kind of have a very quick pass at it, happens when a model becomes kind of widely used and authoritative. And in fact, what happens is that people begin to conform their practice to what is in the model. So contrast this with normative models. Normative models are much more direct. They just tell you this is what you should be doing. The purpose of the model is to tell you what you should be doing. In a sense that some of these other models which come to be performative were not from the start. But they could have been, and some models, I think, are both normative and performative. So depending on what you think about the data on economics undergraduate students who begin to act like rational utility maximizers, you can read that as saying they encounter a model which is a normative model, and they come to act in the way that the model prescribes. But it doesn't have the same, if you read it in that way, it doesn't have the same kind of interesting depth, I think, that some of the discussions about performativity have, because it's so much more straightforward. I'm just telling you what to do through the vehicle of this model, and you're kind of coming to do it. The interesting thing, I think, is that the models in economics have this kind of complex, lingering normativity. They build in some assumptions that are justified normatively. They're partially reread as being descriptive, but often economists are holding on to the kind of underlying normativity of things like the transitivity of preference when they construct these models. So I think it complicates in an interesting way the performativity story, where the models are both changing practice because people are conforming behavior to them, although the model was sort of presented as being a description. But the model, in fact, was not purely ever a description in the sense that it built in some of these normative assumptions, which originate from early decision theoretic thought about the way that one ought to make decisions. So there's a kind of interesting question that I think it would be good to discuss of how the performativity of models is influenced by this underlying normative content. Okay, so let me stop there.
So thank you very much, Joe, for this wonderful talk. And I mean, I guess there are a lot of questions, and so we can open the debate. And okay, we have a first question coming from Federico Giolo. So thank you, Federico, for being with us today, and you can ask your question.
Yeah, thank you for the great talk. Let me say from the start, I'm a political philosopher, so no problem with the mixed issues between normativity and description, and I've been particularly interested in the overall normative implications of your talk. So I'm completely on board with your analysis. My question tries, in a sense, to tease out some further implications concerning, if you want, macroeconomics rather than microeconomics. It's fine. I mean, I completely understand why you began with microeconomics, but we have so many examples in macroeconomics. Consider, for instance, the overall idea that in terms of efficiency, we should have complete capital mobility, no constraints on capital flux, and so on and so forth, which is one assumption of an overall general theory, okay, which is, at least in theory, a descriptive theory. As far as I understand, is presented as a descriptive theory. Correct me if I'm wrong. But then what is the practical implications? The recommendations, the typical recommendations of economists is please remove any barrier in terms of capital mobility so that we will have what? Better efficiency, which is the final end, taken for granted and the only ultimate end. So here we have, at least in my impression, an even clearer representation of the sort of dynamic that you have displayed in terms of hidden normative assumptions that are not presented as such, but then come into play later on in terms of recommendation. To make what? To make reality fit to the model that is not presented as normative, but rather as descriptive. So it's not really a question. I just wanted to hear what you think about this kind of reconstruction.
Thanks, Federico. Yeah, I think what you say is very interesting. I don't really work on macro, being a decision theorist. I'm sort of as micro as you can get. But I think that there are two things that strike me from what you're saying. The first is that I do think that economists occasionally are a little sort of lazy about reading these normative claims off of descriptive models. But I think what the theory of normative models that I present can help us to do is to identify how it is that one should, in fact, derive normative claims from models. And part of what it says is norms in, norms out. So if you don't put in a claim that is normative, you shouldn't be able to generate a claim coming out of it that is normative. So if there is a normative claim, like remove barriers to capital, we should be able to trace back in the model to its sort of source of that normativity. There should be some judgment that underlies the assumption, idealization, whatever it is, in the model, which is kind of doing the work to get that out. And often I think what happens is that when we try to do this tracing back, we find that there is no such compelling justification. So to give you a micro example, economists are broadly against a lot of sort of kinds of risk preferences. They think that you ought to be risk neutral. I think if you attempt to kind of trace back a lot of those arguments, they don't work because what ends up underlying it is not kind of compelling. Now, that's, polemical. People disagree with me about that. But the point is the procedure that I'm suggesting is you have to identify the source. And the source, the normative source, has to come from somewhere else. Models can't spontaneously generate normative claims. You have to have a justification for this thing being a normative principle when you put it into the model. So I think that it gives us some kind of resources for challenging the sorts of claims that you're interested in.
So thank you, Federico, and thank you, Joe. We have another question coming from Nakin Wei. I hope the pronunciation is correct. And thank you, Nakin,
Yes.
for
Okay.
joining us. And
thank you for the very interesting talk. So I think, but one thing that I want to press you a little bit. So you seem to have mentioned that it's an interesting but also surprising fact that models can be read as descriptive idealization and normative idealization. But I was just wondering whether this should be always the case. So what is the use of a normative model if it's not a good descriptive approximation of reality? So then it would seem to be just a story that you're telling, right? So for example, I'm sure you know that in decision theory that there are also these kind of controversial cases like Newcomb problem, whether you should be evidential. So evidential decision theorists would say, oh, I like to be rich, call me irrational, whatever you like, right? So.
Yeah, thanks. I think that's right. I think that it is important that the model has to sort of function well enough descriptively. And that's something that I would definitely like to think more about, because I had this picture, you know, where we're describing the ideal agent and we sort of bring together the descriptive part and the normative part. But you're right that if the descriptive part is too badly wrong, then the model doesn't work. So I don't yet have a kind of full account of how that works. I mean, there's one thought that you might have, which is maybe you want to start with the normative part and you fill in the model as much as possible with just the normative claims. You should have transitive beliefs. You should have whatever the properties of your preferences, beliefs are, but that doesn't get you enough to determine a useful model. So then you have to kind of fill up the rest. And what do you fill it up with? Well, you try to fill it up with descriptive claims about how the agent works. Then that's still not enough. So what do you do? Well, in fact, what you do then is you just make some structural assumptions, like you just assume it's going to be complete and continuous, because that then generates some nice, you know, functions that are easy to work with because you can differentiate them and whatever. Now, if you don't have enough descriptive facts and you add in too many, you know, strange structural assumptions, the model won't work. So it does make this picture kind of more complex, I think. So this brings me back to the question that I dodged in the talk, which is how do you kind of validate and how do you confirm a normative model? It is, I think, quite a tricky question because it has all of these different inputs, the normative inputs, the descriptive inputs, the sort of structural inputs to get the maths to look nice. So yeah, I think it's certainly the case that some normative models or things that people would like to be used as normative models are going to fail because they are the parts of them that are not normatively justified are not descriptive enough.
Thank you.
so thank you very much, Joe. And I see that there is a kind of question coming from Joseph Lehman. Maybe he wants to make the suggestion in presence. I don't know if.
Okay.
Thank
I'm
you.
Joseph
Thank you very
Lehman
much.
from Tel Aviv University, and I really enjoyed this talk. I just wanted to say that I think that economy could be defined as a special case of models. I agree that it is a model for sure, but from the point of view of ethics, these models are also used for a purpose of mobilizing assets and wealth from one segment in the society to another segment. So you can see that the rich are becoming richer and so on. So the models are really built with a purpose to serve some economical, I don't know if you can say values, but this is an aspect that you have not covered, I think.
Yeah, that's right. I have not, and I think that it is important. And in fact, in most cases, maybe it will be more important than what I'm talking about, because those like large scale political and moral questions are so significant. So yes, my goal is really just to look at the explicit normative claims that you can sort of generate, from the model by putting in some normative claims. They, of course, are going to be embedded in a broader practice, which is an ethical or unethical practice, as the case may be. But of course, descriptive models that don't have any of the features I'm talking about could also be used in that way. So there's an important question there about how models are used, and I think there's valuable work to be done in how idealizations, simplifications can be sort of chosen strategically in order to further certain, value-based goals. Yeah, definitely an interesting topic that I didn't talk about today.
Thank you.
So thank you, Joseph, and thank you, Joe. I don't know if there are questions from the audience. Otherwise, I have maybe one or two questions if we have time. I don't know, Joe, if you have time to.
Yeah.
Yeah, maybe. Yeah. I'm interested in your last slide. Sorry, on performativity and normative models. And I was reading your slide. I was thinking of how normative models can change the behavior of the system when agents adapt in a strategical or opportunistic way to the model. And so it's a kind of, behavior that happens in finance, for instance, when you have a model to calculate some value, for instance, the view AER model, the value at risk model. And so institutions use, like banks, use this model to set the limits for the risk portfolio. And people try to adjust their behavior to this value, looking for assets that fit that value, but that it doesn't mean that they are less riskier. So there is less risk in the portfolio, and so in that sense they are changing the behavior of the system, but in an unintended way, and maybe the consequences of the adjustment of the agents to the model should be taken into consideration when you build the model. I don't know if it's clear my point.
I think so I think so. What I am thinking is one kind of situation in which this can occur is if the model is idealized in its representation and in the choices of what things to include, some kind of proxy variable or something is used, which is maybe coarse-grained or represents something in a kind of general way. And it turns out that there are ways of making decisions in response to the way that the model works, which aren't really what the person intended, but which seem to conform to it, like picking assets which seem to have the properties that the model recommends without really de-risking the portfolio or whatever it is you're trying to do. So that can be a mismatch between the objects of representation and the properties that we held on to when we made the model, or the level of detail we included, like how fine-grained the representations are, and the actual behavior we were trying to incentivize. So when doing normative modeling, the kind of choice of how to represent things has this important potential implication that you're trying to direct action, but if you represent in a way that is too coarse-grained, there will be actions which appear to conform with the model, but don't in fact do the thing that you wanted to do. So that's a way of understanding what you've said, which takes it to be like directly normative, which I guess in this case, it maybe it is, maybe it isn't. I'm not really sure. I guess that's slightly different from the second thing you said, which is how should the modeler take into account these changes of behavior? That I guess is more complex. I suppose there are parts of like consumer choice modeling for policy purposes where people attempt to do this kind of thing. Like I spoke to a bunch of economists who were working on like COVID policy modeling, and they were very concerned with modeling the way that people would change their behavior if the policy was brought in, and then sort of iterating the predictions of the model in order to take that into account. I guess that's a very challenging feature of like behavioral intervention modeling in general.
Okay, so thank you very much for your answer. So I don't see other questions coming from the audience. So if nobody wants to make other questions, I think we can stop here.
Okay.
So thanks again, Joe, for your nice talk and your participation in the seminars. And
thank you for inviting me.
See you again here.
Yeah.
Thank you very much.
Thanks,
Thanks
Joseph.
to you.
Okay.